Hi guys! My name is Daniel. And alam niyo naman, it's ECQ, GCQ, MECQ, I don't know where you are. Dahil nga sa worldwide pandemic na nangyari ngayon, nagkaroon ng lockdown sa buong country natin. Ayun, nawalan ng pasok. Since then, umuwi na ako dito sa Valenzuela from UP Los Baños. Dahil doon, mas lalo lang nakaka-stress ngayon kasi dahil nasa bahay ka, meron kang time to actually devote yourself to know what's happening in our country, and to know the current issues. And alam mo yon, yung mga naririnig mo mga balita, it's always not good. It's actually a reliever sa akin na meron kaming mga requirements na pinapasa online because it actually reminds me that I'm still a student and huwag masyadong ma-stress sa mga nangyayari sa paligid. That's why we're gonna learn something new today! Yay! We're gonna learn about this diverse phylum, and this phylum is called the Ascomycota. Ascomycota. So the phylum Ascomycota is also known as sac fungi. The members of this phylum is called the Ascomycetes. Ascomycetes are eukaryotes, which means they have a nucleus with certain number of chromosomes. It also means that they have membrane-bound organelles. This phylum is also under the kingdom Fungi. Some Ascomycetes are also saprophytic, which means that they live on dead matters or dead organisms. Some are also parasitic, and some are also coprophagous, which means that they live on or eat dungs. DUNG or feces. Most of the members of this phylum are multicellular, but some of them are also unicellular. As we may know, yeasts are eukaryotes, yet they are unicellular. Also, they give off spores, and that's one way of their reproduction. They're also the largest phylum of fungi, with about 60,000 species under this division. Most of them live on land, live on lakes, rivers, seas, but some of them also live in Antarctica, which is amazing. Ascomycetes can reproduce asexually or sexually. The structures that are common in Ascomycetes are septated hyphae for multicellular organisms and pseudomycelium for unicellular organisms. So that's it for today. Tomorrow we're gonna talk about why they are called sac fungi. Also, I'm gonna start something really fun. I'm gonna start it na tomorrow because matagal siya. See you tomorrow on day 2! So hello, welcome back. It's day 2. So first we're gonna talk about why is it called sac fungi. So first of all, it's because of their sexual spores called the ascospores that are reproduced in the sac called the ascus. The members of the phylum Ascomycota also include some molds that have septated hyphae and some yeast. So it's actually kind of weird that in this phylum we'll encounter both multicellular and unicellular organisms. Even though they really look different, they're actually similar when it comes to their DNA. They are grouped based on the DNA analysis. So ngayon, sasabihin ko sa inyo kung bakit ba ako pag napagod. Kasi, well, wait. Kasi one of the members of the Ascomycota is the species Saccharomyces cerevisiae, or also known as the baker's yeast. So it has a lot of use in food production because of the process of fermentation. And we're gonna talk about a lot of that in the following days. This Saccharomyces cerevisiae can be used in the fermentation of breads and also in the making of wines and liquors. So kanina, I made some wine. Plus 18! Plus! I'm already 19, so I'm allowed to do this. That's why kahit day 2 pa lang, ginawa ko na. Kasi by day 14, iinumin natin! Plus 18 plus! Papakita ko sa inyo how to make a simple red wine at home!
This recipe is made by JakeLane17. Here are the ingredients. Make sure that the grape juice that you've bought doesn't contain any preservatives or colorings. We're gonna remove 1 cup of grape juice from the bottle. Then we're gonna add 1 cup of table sugar. Using a funnel makes this step a lot easier. And then we're gonna add 1/3 teaspoon of instant dry yeast. This is the Saccharomyces cerevisiae. It will ferment the juice by converting the sugar added into carbon dioxide and ethanol. And then we're gonna secure the lid so that we can shake the bottle and make the sugar and yeast to mix and blend well with the juice. This part is optional. We've poked a hole in the bottle's lid so that we can put in the airlock. The airlock helps the gas from the inside to escape and to prevent air from the outside to go in. And then let it sit on a dark and warm place. It takes 10 days to finish the fermentation process, but it can age up to months or even years.
Ganoon ang process how to make your home brew or your own wine at home. See you tomorrow! The thing is, a single spore of Ascomycetes can actually carry out 2 types of different life cycles. So it means that both multicellular or unicellular Ascomycetes can reproduce asexually or sexually. But today we're gonna first talk about the asexual reproduction of multicellular Ascomycetes. And Precisa will be our model organism for today. Yay! So I prepared a short and simple animation to show you how the reproduction actually looks like, but it's just a very oversimplified version, so please bear with my animation skills because it sucks. The reproduction starts off when a haploid spore met the right conditions for germination. For example, it landed on a dead animal or dead organism. It then begins to multiply through mitosis, reproducing more haploid cells. These cells create a tube-like structure called hyphae, which are the main mode of vegetative growth for fungi. The hyphae can grow continuously or they can branch out. In Ascomycetes, their hyphae are divided into cellular compartments by walls called septa. Septa allows molecules, cytoplasm, and some organelles to move between the cells. When these hyphae keep growing, it will form a mass called mycelium, which is just a collection of all the hyphae. By the way, they look different for each species. When the hyphae are formed and the conditions are right, the Ascomycete will form a new structure called the conidiophore. This structure asexually releases spores called the conidia, or conidiospores. These spores break off from the conidiophore and are carried out by any medium such as wind, water, or animals to reproduce and germinate once more. So that's how asexual reproduction of multicellular Ascomycetes work. And tomorrow we're all gonna talk about how Precisa or multicellular Ascomycetes reproduce sexually. Cause they can. Cause they're just amazing. They can reproduce asexually or sexually. It's just mind-blowing. Good day, guys! Ito, kakaligo ko lang. Pero wala na akong time para patuloyin pa because we're gonna talk about the sexual reproduction of multicellular Ascomycetes. Like right now, buckle up, guys, dahil mahaba-haba to. Let's go! In Precisa, there are 2 spores of different mating types. First is the plus spore, then the other one is the minus spore. When optimal conditions are met, these 2 spores are going to germinate and form branched septated hyphae. Both hyphae are made out of cells that contain single haploid nuclei. Remember, haploid means having only half of the usual numbers of chromosomes in a cell. The number of chromosomes will vary on each species. Septated hyphae from both spores will continue to grow, and when they come close to each other, they will fuse together. The result is a single cell with 2 haploid nuclei or also known as a dikaryotic cell. This stage is called plasmogamy. This is the process of fusing two hyphae from different mating pair, or simply a cytoplasmic fusion. In the dikaryotic cell, the nucleus from the plasspore is now called the ascogonium, while the nucleus from the minospore is now called the antheridium. This is analogous to the human gametes, which are the egg cell and the sperm cell, so you get it.
I'm a savage.
As the dikaryotic cell continuously divides and produces more cells, the two nuclei will remain separated until the hyphae is ready to produce sexual spores, while the branches from the two original hyphae will still have only one haploid nuclei reproducing asexual spores. The dikaryotic cells will form a special type of hyphae called the dikaryotic hyphae on their very tips. The network of single haploid nuclei together with the dikaryotic hyphae will form a fruiting body, or the ascocarp. The ascocarp is supported by the vegetative hyphae or mycelium that are below the ground. So, ayun na muna guys for today. We're gonna continue it tomorrow. So, good night! Hello guys! Wala na patumpik-tumpik pa. Let's continue. Now, going back, the dikaryotic hyphae is where karyogamy will take place. Karyogamy is the fusion of the two nuclei to form a single diploid nucleus. An intermediate stage called dikaryophase can happen, in which karyogamy is delayed. The diploid cell will undergo meiosis and will form 8 single haploid nucleated sexual spores called the ascospores within an ascus. Asci is the plural for ascus. Ascus acts like a sac, hence the name sac fungi. As the asci mature, the sac will rupture, and the ascospores will be released into the air to repeat the life cycle. Here in Peziza, the interior of the ascocarp consists of millions of asci containing ascospores. You can see that in the surface of the ascocarp, we can see the asci, and then it's like a pea pod with the ascospores inside, which is like the piece inside of the pea pod. Remember that the asexual spores or the conidiospores still exist on the hyphae of the original two mating spores and can also be supported by the vegetative hyphae. So that's it for today guys. See you tomorrow! Good evening guys! And ayan, vlog na naman ng gabi si ate mo girl. Pero today, we're all gonna focus about our model organism for this past 2 days, which is the Peziza. So Peziza, which has more than 100 species, belongs to the family Pezizaceae. Pezizaceae. From order Pezizales, class Ascomycetes, of course, and from division Ascomycota. The division Ascomycota is characterized by absorptive type of nutrition and absence of multispores in each membered species. As a part of the Ascomycetes, Peziza has a potassium as their ascocarp or their fruiting body. Their body shell ascocarps produce heavily exposed hymenium at maturity. Hymenium is the tissue layer on the surface of the ascocarp. Like mushrooms, Peziza produces an above-ground reproductive structures that come from an underground mycelium. Even though most of the members of this genus are of unknown edibility and are difficult to identify as separate species without use of microscopy, certain morphological characters are used to distinguish different species. For example, Peziza praetervisa is recognized by its flattened purple cup-like fruiting body, while Peziza domiciliana is a brownish cup fungus and the Peziza cerea is a yellow-gray fungi and measures less than 5 centimeters across. In general, the species of Peziza have no substantial or economical use, which is kind of sad. However, the species found growing on soil have a tendency to increase soil fertility. Species growing on woods or logs lead to deterioration of the timber. Species growing indoors are potential pollutants, and unique types of lectins have been isolated from Peziza arvenensis. These lectins are carbohydrate-binding proteins and has biotechnological importance. So as you can see, Aziza has really no economical value or importance. It's just more of like a model organism for the multicellular Ascomycetes. Well, according to my Google search. So see you tomorrow for the continuation of our vlog. So after taking a look at the life cycle, the two life cycles of multicellular Ascomycetes, let's take a look at naman the unicellular Ascomycetes. You know, the yeast. In this case, the species Saccharomyces cerevisiae will be our model organism. Parati siyang minomodel, no? Di naman ganun kaganda. So just like the Pizziza, Saccharomyces cerevisiae can reproduce asexually or sexually. This can be done through the process of budding, fission, or conjugation. But today, we're going to talk about the asexual reproduction first. We're gonna start off with a single yeast cell in a rich nutrient environment. In this environment, a yeast can undergo budding or fission. But cerevisiae only undergoes through budding, hence the name budding yeast. So let's start with that first. During this asexual stage, the haploid nucleus is duplicated by mitosis. The mother cell will grow bud on the edge, in which it would give off a complete set of chromosomes to that bud. Sometimes, due to repeated and rapid budding, yeast cells appear in one or more chains. This is called pseudohyphae or pseudomycelium, because these chains resembles a filamentous or septated hyphae. But unlike the filamentous hyphae, pseudohyphae do not have septa on their conjunctions. Rather, they have constrictions. Now, as the bud grows, it will detach to the mother cell and become an independent yeast cell, just like teens turning 18. Charot. The second type of asexual reproduction for unicellular Ascomycetes is fission. Fission does not happen on Cerevisiae, but it does on Schizosaccharomyces pombe. So, singit lang natin yan. In fission, the mother cell will still divide chromosomes by mitosis, but it will divide into equal halves. Then the two daughter cells will also eventually grow as mother cells. So that's it for the asexual reproduction of the unicellular Ascomycetes or these yeast. It's simple, budding or fission, but tomorrow we're gonna talk about their sexual reproduction. Sexual reproduction of the Cerevisiae! Now let's have a short recap about what we talked about kahapon. A haploid spore can asexually reproduce through budding or fission, and these newly produced cells can eventually reproduce asexually too. But the thing is, different spores of different mating types can also occur on yeast cells, namely the types A and alpha, instead of plus and minus. When two different mating types come close into proximity, they send out chemical signals that will initiate conjugation. Sexual reproduction will begin at the point of conjugation. The two yeast cells will fuse together and so do their two haploid nuclei to bud and germinate a diploid daughter cell. This single diploid daughter cell can undergo asexual reproduction or mitosis, but ultimately, it can also undergo meiosis, in which its nucleus will be divided and form 4 haploid ascospores surrounded by an ascus. These ascospores can eventually get out from the ascus and grow and germinate again. And that's it for the reproduction of unicellular Ascomycetes. So that's it for today. Good day and good night. Hi guys! Today, I felt cute today. I'm wearing a kimono from Japan. So today, we're gonna talk more about our model Ascomycete, unicellular Ascomycete, the Saccharomyces cerevisiae. Yay! Saccharomyces cerevisiae belongs to the family Saccharomycetaceae, order Saccharomycetales, class Saccharomycetes. The cells of Saccharomyces and other single-celled Ascomycetes are typically spherical, oval, or cylindrical, and cell division typically takes place by budding. Yeast cells are typically much bigger than bacterial cells and can be distinguished microscopically by their large size and by the obvious presence of internal cell structures. Yeast flourish in habitats where sugars are present, such as fruits, flowers, and the bark of trees. Yeasts are typically facultative aerobes, growing aerobically as well as by fermentation. The species is most popular as a fermentation agent to rice breads, to turn grapes as wine, and starches into beer. And due to its high fermentation process and high productivity of ethanol, Saccharomyces cerevisiae and its strains are used for bioethanol production as well. Syempre, hindi mawawala ang pagka-model nitong Saccharomyces cerevisiae na to, no? Diyos ko naman, ganda-ganda to. Ang ganda mo, girl. Like, nasa'yo na ang lahat. This species is considered by many researchers as a model eukaryotic organism because of its low cost, fast production, completed genome sequence, and as an economic driver. So, titignan mo talaga to sa Saccharomyces cerevisiae na to. Palong-palo talaga, no? That's why tomorrow, we're gonna do something really, really exciting. It involves Saccharomyces cerevisiae as a living agent. Hello guys! So, kanina, I did something really cool. I baked! I fried some donuts! And today, I'm gonna show you what I did. It's very tiring. Pero it's worth it because the donuts taste so good. It tastes so good. Let's roll the ingredients for baking custard cream filled donut.
yung donut. Naubusan ako ng custard cream. That's why donut na lang. How? Ang sarap ng dead cells na Saccharomyces. So, yeast like Saccharomyces cerevisiae has been used by bakers or by pastry chefs to rise their dough through the process of fermentation. Fermentation is the process of converting sugar into carbon dioxide and ethanol. In baking, you can actually see it works when you let the dough roast for an hour. Sa process na yon, yung yeast or yung Saccharomyces, kinakain niya yung sugar na nilagay mo, and yung byproduct niya is carbon dioxide, kaya siya lumulobo. Natatrap siya ng dough. That's why it creates bubbles. There's like gas inside. So that's it for today. See you tomorrow. Hello! Today we're gonna talk about a really interesting member of the phylum Ascomycota, that is the genus Penicillium. So Penicillium belongs to the family Trichocumaceae, order Uroshiales, and from the class Uroshiomycetes. Penicillium are ubiquitous soil fungi, preferring cool and moderate climates, and present wherever organic material is available. Commonly known as molds, they are among the main causes of food spoilage, and many species produce toxin called mycotoxin, which is capable of causing disease and death to humans and animals when consumed. Penicillium spores are often found in air and dust found indoors. Mold spores may enter from the outside through open doorways, windows, heating ventilation, and air conditioning systems. They thrive and grow the best on places where there is excessive moisture, such as roof and windows with leak, or where there has been flooding, and they can begin to grow and multiply. But of course, the penicillium is best known as the fungus that produces the antibiotic drug penicillin. Penicillin was characterized by British scientist Alexander Fleming in 1929 as the first antibiotic or as an antibacterial compound isolated from the species Penicillium chrysogenum. Penicillin can be used to treat bacterial infections such as pneumonia and other respiratory tract infections. Some species of penicillium are also used in food production, such as production of blue cheese and improvement to flavor of ham and sausages. So as you can see, penicillium has a really variety of uses. It can be a cure, but it can also be deadly. So we're gonna talk about more fun facts about this phylum tomorrow. Good afternoon, guys! This is the 12th day of my vlogging, and today we're gonna talk about some edible Ascomycetes, specifically morel mushrooms and the ever so expensive truffles. First off are the morels or the true morels. True morels are from the genus Morchella. These distinctive fungi have a honeycomb appearance and are used as a gourmet ingredient specifically for French cuisine, while truffles come from many genus of fungi such as tuber, diopora, peziza, and over 100 others, and are used mainly in many European and Middle Eastern cuisines. So these truffles are really expensive. They can cost for thousands of dollars per pound. So it's expensive because of how hard it is to find and how hard it is to cultivate. Other Ascomycetes can also cause diseases, specifically plant diseases, one of which is the Dutch elm disease, which is caused by species from the genus Ophiostoma. This disease affects elm trees and is spread by elm bark beetles. There's also the chestnut blight, which is caused by the species Cryponectria parasitica, a parasitic fungus of the chestnut trees. And there's also the apple scab, which is caused by Venturia inequalis. So that's it for today. See you tomorrow. Hello, it's the 13th day. Today we're gonna talk about Ascomycetes existing in extreme environments. The first one are the psychrophilic fungi or the cold-resistant fungi. These are the fungi adapted to grow at low temperatures and have optimal growth at 0 to 10 degrees Celsius. Some examples of these are the snow molds, including the Ascomycetes Microdochium nivale. Microdochium nivale is a pathogen that causes fusarium
patch. Fusarium patch is a disease in many cold season turfgrass in North America. There are also fungal contaminants which occur in frozen food products. This includes some species of, you know it, genus Penicillium and Cladosporium, which can contaminate meat even in cold storage. The second ones are Ascomycetes existing in Antarctica. Like the Penicillium antarcticum.
This genus is really something, huh?
Most of the fungi recorded in Antarctic continent are anamorphic, but a few exceptions have been recorded, such as the Lobolus species that have been conveyed to reproduce sexually even in those temperatures. Now there's also soft rot fungi found in Antarctica that causes the decaying of wood. When waterlogged wood is in contact with ground, species of the genus Cadophora can grow but are only active during summer when the ground is thawed. Third one is the thermophiles. Thermophilic or thermotolerant fungi are adapted to grow at higher temperatures. They can achieve optimal growth between 40 to 50 degrees Celsius. Examples of thermophilic Ascomycetes are Thermomyces lanuginosus and Thermoascus aurantiasis. Fourth one is serotolerant fungi. Serotolerant fungi grow in material with low water content or those that grow in very dry environments. Aspergillus contains the most serotolerant species like Aspergillus glaucus and also a few from genus Penicillium. Again, these are also important as food spoilage agents in dried foods at above 12% water content. At the same time, serotolerant fungi also contains mycotoxins, so food may be unusable even if not obviously deteriorated. Tomorrow we're gonna taste the wine that we made for the second day and let's see if it actually tastes good. So, good morning guys! Oo, good morning. It's the last day of the vlogging, kaya medyo na-excite ako. And ito, kinuha ko na siya! This is the wine tasting! So, ito na yung ginawa nating wine. According din sa YouTuber, is tapos na yung fermentation by 10th day or 9th day. Kaya okay na siyang i-consume ngayon. Grabe yung amoy. Cheers. Ang tapang niya. Sobrang tapang niya. I like it. Put it more. Kaya naman, sasabay ko na lang siya sa kanin. Yan. Breakfast tayo. With wine. Umaga-umaga. So, this vlog has finally reached its conclusion. For this past 14 days, I've learned a lot about the phylum Ascomycota, like its structures for its unicellular and multicellular Ascomycetes and their reproduction. We've also made and tasted some cheap fermented wine and fried some donuts, even though I suck at it so much. And we've discovered more about the distinct members and genuses in this phylum, such as the Penicillium, and their application to everyday life. I feel really happy that I have this privilege to study microbiology because I get to learn these fascinating things, not just about the fungi, but also about bacteria and viruses, especially right now that we are in a pandemic caused by a novel coronavirus. It really enabled the people, even the commoner ones, to be educated about viruses and how it affects people, the mode of transmission, the symptoms, and how people can prevent getting it. And I realized ko how these viruses, bacteria, fungi, like these pathogenic microorganisms can be so fatal and they cause a really big devastation, a really big destruction in a society. Not just the health sector, but everything is affected. Mas lalo na currently dito sa Pilipinas na ang dami-dami ng cases pero
pero wala pa ring mass testing. Ang daming walang trabaho, ang daming nagugutom, kung ano-ano yung inuuna, franchise ng ABS-CBN, terror bill na malapit na maging terror law, manyanita, like, nakakaloka. So, thank you very much for watching this vlog. Always stay safe and stay healthy to whomever is gonna watch this. Right now, the only thing that we need to do is to survive. We can't push ourselves to be productive every day if we cannot because of the circumstances right now. Ang mahalaga is buhay tayo, lumalaban tayo, and yeah, keep on fighting lang. Babalik din sa normal ang lahat. Ayun lang, maraming salamat sa panonood. Goodbye!